Now let's talk about plotting complex numbers. When we plot a complex number, this is just like plotting it on an x and y axis, except this time our axis is made up of an imaginary axis on what's usually the y and a real axis on what's usually the x. And then to plot this, we take our real part and we go to that on our real axis. So we have a 5. 5 would be right about here. Our imaginary part is 3i. So we go to 3 in our imaginary axis, which is right here. So our point 5 plus 3i would be right about here. If I wanted to plot negative 4 minus 2i, I'd go to negative 4 on my real axis, which is right here. And I go to negative 2 on my imaginary axis, which is right here. And where those two are, we'd have a point right here. And this is the point negative 4 minus 2i. Now the last thing we have to learn about is taking the absolute value of a complex number. If I had the absolute value of a plus bi, that's just equal to the square root of a squared plus b squared. So if I wanted to take the absolute value of 6 minus 7i, I would just plug in 6 for a and negative 7 for b. So we'd have the square root of 6 squared plus negative 7 squared. 6 squared is 36, and negative 7 squared is 49. And we still have to take the square root of this. 36 plus 49 is 85. So we have the square root of 85. The square root of 85 doesn't reduce, so it's just the square root of 85. And that's the absolute value of 6 minus 7i. If we have the absolute value of 4i, now notice this complex number doesn't have a real part. This is 0 plus 4i. And if it doesn't have a real part, we call this a purely imaginary number because it only has an imaginary part. But if we write it as 0 plus 4i, then we can take our absolute value of it. 0 would just be our a, and 4 would be our b. So this is the square root of 0 squared plus 4 squared. 0 squared is 0. 4 squared is 16. The square root of 16 is just 4. So the absolute value of 4i is just 4. So now that we know what complex numbers are, let's see how they apply to quadratic equations. Here we have 4 times x minus 2 squared minus 10 is equal to negative 110. Well, first we need to get this x squared by itself. So I'm going to add 10 to both sides. We'll have 4 times x minus 2 squared is equal to negative 100. We can divide everything by 4. We'll get x minus 2 squared is equal to negative 25. If we square root both sides, remember if we take the square root of a square, we end up with the absolute value of x minus 2. And this is equal to the square root of negative 25. Well, I can rewrite the square root of negative 25 as the square root of negative 1 times 25, or as the square root of negative 1 times the square root of 25. Square root of 25 is just 5. So what we end up with is the absolute value of x minus 2 is equal to 5i. Now if the absolute value of x minus 2 is equal to 5i, if we drop the absolute value, we have to consider both the positive and negative versions. So what we get is we get x minus 2 is equal to 5i, and we get x minus 2 is equal to negative 5i. Now for this first equation, we add 2 to both sides, and we'll get x is equal to 2 plus 5i. So here is one solution, or 0 for our quadratic equation. If we look at our second equation, again we add 2 to both sides, and we'll get x is equal to 2 minus 5i. So here's our second solution, or second zero of our quadratic equation. Usually we'd write these together and we'd say x is equal to 2 plus or minus 5i. And these are the roots or solutions of our quadratic equation. And that completes the tutorial on complex numbers.